So for Monte Carlo simulation, what are the two data? What is what are the two parameters which are required to start with? You need the mean. And what is the mean? Mean is 50. You also need the standard deviation. Standard deviation is how much? Standard deviation is 10. ठीक है ना? And we need to do 30,000 iterations. Don't make the mistake of dragging for 30,000. You'll keep dragging only otherwise. So I will just mention the iteration here. Starting from 1, going up to 30,000. And go to series. I need 30,000 iterations. So this way I'll get to 30,000 much faster. So I go up to 30,000. And then I create the random distribution, random values using the norm.inv function. Norm.inv probability के लिए. Now please realize when you're creating random numbers, the probability has to be a random number. And you can generate that using the RAND function, random. RAND and then bracket open and bracket close. Bracket open and bracket close. So random number generate हो जाएगा. Comma mean and standard deviation. So mean I'm going to take as 50. Standard deviation I'm going to take as 10. And बस इतना ही करना है and then double click. So all your random numbers will get generated. अब वो सेम नहीं होगा. Don't try and compare. कोई जरूरत नहीं. मैंने लिंक किया ही नहीं है. मैंने लिंक नहीं किया. Now how will you, what you should do, interesting, go to the first cell, control shift down arrow, and look what you see here. What do you see here? Average as 50.03. Now हो सकता है आपका अलग हो, because this they are going to generate a average, the random number generation for every one of you. For each one of you, the random numbers generated will be different. Same नहीं आए. किसी का कुछ आएगा, किसी का कुछ आएगा, and it can keep changing. So if I press F9, ये देखो इधर, just go to the first cell and press F9. वो चेंज होता रहेगा. देखो फंक्शन F9 फिर से चेंज हो गया, फिर से चेंज हो गया, फिर से चेंज हो गया. It will keep changing. Can you see how the numbers are changing? So if you press F9, it keeps changing. Now random numbers are generated now. So what does this become? This becomes your input range. The input range was created using the norm inverse function, which had the random distribution, random probability distribution embedded in it. Next thing is to create the bin range. Now, I have to do for the bin range, the confidence interval is mu plus minus 3 sigma. So what is mu plus 3 sigma? Upper limit, mu is 50, 3 times sigma is 30. 80. So 50 plus 30 is 80. And for lower limit, 50 minus 30 is 20. So my mu plus minus 3 sigma will be lying between 20 and 8. वो क्या करेगा ना, it will help you to plot the bin range. So those histogram bins, it buckets it. So 20, the best way to do it is take a range of 2. So 20, 22, 24 and go up to 80. So यहाँ पे I'm going to create my bin range. Mu plus minus 3 sigma. So I start with 20 and go up to 80. Keep a step value of 2 and a stop value of 80. तो आपका bin range भी create हो गया. Yes or no? So now you have the input range also and the bin range also. Now go to your data and data analysis tab में जाइए please. If you go to the data analysis tool pack, can you see histogram here? If you go down, ANOVA, correlation, covariance, histogram, ये देखो. This is your histogram. दिख रहा है? Yes or no? Data analysis pack में दिखेगा. And press OK. So now it is going to ask you the input range and the bin range. So input range हमको पता है कौन सा है. Which is the input range? This is your input range, the random distribution. 30,000. ये जो 30,000 iterations है ना, that is your input range, starting from here to here. What is your bin range? The one which we just created, 20 से 80 वाला, this one. 20 to 80 is your bin range. ठीक है ना? Output range आप same worksheet में ले लो. No need to go to a new worksheet. Just next to the bin range somewhere here, you can create output range. And नीचे 3 option है, Pareto, cumulative percentage and chart output. So just click on chart output. Chart output. Click करो and press OK. Now the moment you press OK, what happens? ये देखो बन गया ना. So this is your normal distribution curve, histogram along with your bin and your frequency. Clear? Now I can also create a probability distribution. Type here. I can also create a probability distribution. Can anyone tell me in this class, how can I create the probability distribution? How do I create a probability distribution? Anybody? Bolo? How do I create a probability distribution? I can just do this, no? Every frequency divided by 30,000 because there are 30,000 iterations. So every frequency divided by total number of events, which is 30,000, will give you my probability. And इसको double click करो. How do I know that this is right? Is there a way to check it? Yes, summation should be equal to 1. Very good. So I'm going to do my sigma or my summation. That should be equal to y. Summation should be equal to summation of probabilities should add up to 1. It is adding up to 1, isn't it? ये देखो. Isn't it adding up to 1? It is. That means your probability distribution is correct. Now I can also create a scatter diagram which will create a normal distribution curve. So pay attention on this one now. I will select my probability distribution like this. Go to insert, recommended charts, choose the scatter. ये देखो. देखा आपने? So if you choose the scatter diagram also, you will get a. Now this curve may not look exactly like a normal distribution curve. थोड़ा सा distortion है. दिख रहा है आपको ऊपर? There is a little bit of a distortion. Can you tell me why that distortion happens? If you increase the size of the population, make it 40,000 rows, 50,000, जितना ज्यादा बढ़ाते जाओगे उतना वो closer to normal होता जाएगा. That's the reason why it's slightly distorted. And then you can choose whatever design you want, whatever color you want. कुछ भी कर सकते हो. Wow. So this becomes your scatter diagram for the normal distribution curve. Is it clear? I'll give you a very interesting application of in VAR modeling. So if you just pay attention on the screen, this is a loss data that I had. Okay, which had a loss distribution at a mean, return distribution at a mean of 18% and a standard deviation of 25%. What I did was I used the normal distribution function. Can you see this function? Normal distribution for every return using this as the mean and this is the standard deviation. I created the cumulative probabilities. And how do I get the individual probabilities from the cumulative probabilities? So suppose चार बच्चों के मार्क्स 40 है, 5 बच्चों के मिला के 48 है, तो पांचवें बच्चे का कितना मार्क्स हुआ? 8. What did you do? Cumulative probability minus the previous cumulative probability. So that's how I get my individual probabilities. Once you get your individual probabilities, I can just select the individual probabilities and create what is the. Now you see this one is an exact normal distribution curve. Now how do you interpret the VAR here? It can be estimated with 95% confidence that the return is greater than X%, which means that 95% of your observations, 95% of the observations will be here. क्या बोल रहा है question? It can be restated that with 95% confidence that the return is greater than X%, which means that 95% of the observations are to the right. So what is that value? What is that value of X? So do you know Z in a normal distribution? Z value is, sorry about using the red pen. Z is equal to X minus mu by sigma. Now I use 95%. अगर 95% इधर है, तो 5% will be on the left. Are you with me? If 95% was on this side, 5% is on that side. Remember when I'm looking up the Z table, the Z value always reflects the area to the left of the curve. तो मुझे 5% lookup करना है, not 95%. So if I open my Z table, let me open the Z table and show it to you. परसेंटाइल भी लगा सकते हो और ये भी कर सकते हो आप, norm.inv भी कर सकते हो. Just give me 1 second. So if I open my Z table and look up 0.05, 95% ना, तो मुझे 0.05 चाहिए. तो 0.05 कहाँ आता है? देखो 0.05 comes in between these two numbers. Huh? No. Average. So 0.05 is between these two. So minus 1.645 होगा, correct? Minus point, so I can take minus 0.165 or whatever. So I take this value, minus 1.645. That is equal to x minus mean by sigma. So what is x? You can find out x. X will be minus 23.125%. ये क्या है? What is this number? Minus 23.125%. What is this? Minus 23.125%. This is your value at risk. Because 95% of the observations are higher than this number. 95% of the observations are higher than this number, which means that I can state with 95% confidence that the losses will be restricted to 23.125% of your portfolio value, but a 5% chance that the losses will exceed 23.125% value. So, if I look up this part here, ये देखो 23.125 negative is coming between what range? 0.04648 and 0.0505, which is that 5% confidence level. Cumulative probability is 5%. समझ में आया आपको? So there is a definite correlation between the data that you do, and you can also obtain this z value using the normal function. So if I do this is equal to norm dot s dot inv and I put 5%, I will get the same number, minus 1.645. देखा आपने? Can you tell me why I use norm.s.inv? Why did I use norm.inv? Standard normal distribution. जो z value होता है, when we are capturing the z values, it refers to a standard normal distribution. Standard normal distribution has a mean of 0 and standard deviation of 1. So that's what captures your z value. Your z tables are all outputs of standard normal distribution. So when you have to limit it to a standard normal, you should use norm.s.in. If you're doing it only for a normal distribution, it has to be norm.in. Now, how did you find out that this exercise that we did now, how do you know this is not a normal, this is not a standard normal, this is a normal distribution? Because the mean is not equal to 0 and the standard deviation is not equal to 1. So this cannot be a standard normal distribution. It can only be a normal distribution. समझ में आया आपको? And that's how you construct the normal distribution curve. And this is extensively used in VAR modeling. But mind you, this also becomes one of the major limitations of value at risk. Because value at risk therefore assumes that your return distributions are normally distributed, जो जरूरी नहीं है. For example, normal distribution की कुछ properties है. Mean is equal to median is equal to mode. There is no skewness in a normal distribution, which means you have 50% of the observations on the left tail, 50% of the observations on the right side. So no skewness, and kurtosis उसका 3 होता है. But equity, अगर आप equity securities के returns लो तो वो normal distribution के properties को adhere नहीं करते, because there are severe events also which takes place. The COVID distribution was a severe event. The subprime lending crisis which happened 2 decades ago was a severe tail event. So equity distributions have fatter tails. So they display a fatter tailed kurtosis. Excess kurtosis बोलते हैं उसको. And that's not normal. So equity distributions actually are not normally distributed, and that's one of the major limitations of value at risk using normal distribution properties. इसीलिए VAR की जगह people have started using expected shortfall Expected shortfall provides a magnitude or severity of the losses. It doesn't restrict to a threshold value. So this was one of the uses of Monte Carlo simulation in statistical modeling with respect to market risk. Okay. So I'm going to share this file with you, and that brings us to the end of this part. If you have any questions, please ask.